Our community is situated along the beautiful Tennessee River in Sheffield, Alabama. Locals can be found boating, fishing, skiing, and enjoying time in the luscious waters. Tourists come to the area to see the gorgeous sights along the river's edge. Many are unaware of the invasive species that lurk below the surface.
When my teacher pitched the Samsung Solve for Tomorrow project, I knew it was a perfect way to involve zebra mussels and find out more about them.
These tiny mollusks are causing biofouling in both power plants and industrial water systems. They also have a financial impact for the 13% of our community that lives on the river.
We spent the first week looking over years' worth of research. Our two guest speakers were Mr. Dennis Baxter from the Tennessee Valley Authority and Mr. Bill Isom, a world authority on zebra mussels. We realized we were working on something big. There is no possible way to get rid of the mussel completely, but we can help industrial plants and our local citizens that live on the water.
TVA set out a boom boat with a robotic arm to dig up mussels from the bottom of the Tennessee River. Since the 4th grade students are helping us collect observation data, we brought a few along with us to gather our mussels. Together we observed their behavior, reaction to different coatings, and studied their anatomy under the microscope.
We designed and 3D printed a prototype of an attachment that will allow homeowners to efficiently clean their motors and pipes of the mussel larvae, which will help avoid motor fouling in their pumps.
Raw water usage for cleaning purposes suck in villagers by the intake, which are then carried into condensers of electrical generating facilities. Here they attach themselves to the walls. Over a short period of time, they grow and ultimately obstruct the flow of water. Ironically, the cleaning process is causing the need for more cleaning.
Our goal is to find a way to lower the dam's intake to bring water in from a lower level. This will reduce the number of villagers brought into the plant. Wisdom Dam was designed to use natural water pressure against the dam wall to push water into the intake. Therefore, we have to help find a way to lower the intake without adding additional power sources.
We tried several different piping configurations on a much smaller scale. The Wisdom Dam intake pipes are 10 feet in diameter. So for our work in the classroom, we designed a dam wall and intake opening with a ½ inch representing 1 foot.
After multiple designs, we came up with one that works with the natural water pressure because of hoses that are far enough down to avoid collecting villagers.
Community awareness is the number one way to stop the spread of the mussels. After our initial survey, 78% had little or no knowledge of the mussels or did not know of their harmful effects on the ecosystem and facilities. 89% were willing to take the extra step in making sure not to spread zebra mussels. Our next step is community outreach to spread the information.